Hello students, and welcome to this lesson on transformations of logarithmic functions. Your objective today is that you will analyze transformations of exponential functions using journal notes and practice problems. So we've talked a little bit about the logarithm and about what it does and about how it works as a function. We'll go into it a lot more next week, and we'll actually talk about more applications of it. We've learned a lot about it as a function, but not a lot about it as far as being something that we are using in the real world. And I know that I say this all the time, but a logarithm is used everywhere, especially when you're looking at applications in science. Anywhere where you see an exponent used, you typically are going to see logarithms used as well, especially if you're trying to backtrack where you came from. So we're going to talk about transformations today. I know this is your favorite subject. So real quick, these transformations will be almost the same exponential functions. So we have log base b of x plus d, and this is going to be left and right shift. I'm sorry, this isn't left and right, this is up and down. So if d is greater than 0, then it's up. D is less than 0, it's down. And this is very familiar to you guys. You've done this transformation before. This is going to be left and right. And I'm going to start using this word translation. Translation just means a shift. So it's just a better word for what we're doing. And we see that if c is greater than 0, it's going to be a right shift. And if c is less than 0, it's a left shift. Now remember, this sign right here is negative. So if c is greater than 0, the way that this is going to appear is that let's say that c is equal to 1, then you have x minus 1 in here, because the sign isn't going to change. It's going to stay the same. If you have c is equal to negative 1, then what you're really saying is x minus negative 1, and that's what's going to create the positive here, is that double negative creates the positive. And then finally, let's talk about a again. This is going to be your stretch, compression, and reflection. So if a is greater than 1, we call that a stretch. If a is less than 1, we call that and greater than 0, we call that a compression. And then if you have a negative a, then that's going to be a reflect across the x-axis. All right, so let's go ahead and take a look at some examples. So these examples, I'm only going to do the one of them on each page, but you guys should also do these examples. So let's just talk about log base 2, 3. So again, we're going to start seeing that this is going to be rather difficult as far as graphing goes, but what I would do is take your parent function, right? You know how to graph these points by now. So you have 0, you have at 2, you're at 1, and then at 4, you're at 2. And then you've got something like that. And you know that it's going to be stretched by 3. So every point will be stretched by 3. So our new function will be, you multiply all of the y values by 3. So you have 1 will become 3. And then 2 will become 6. So that's going to end up way up here. So at the same time, these are going to get a little bit stretched too. So you're going to see this very weird stretching of this happening. All right, and then here you have negative 1/2. So again, do your parent function. 1, 2, 3, 4, 1, 2. All right, so you've got such. And then not only are you going by half, so this will become 1, but it's also going to flip over. So all of these points, it'll still go through this point here, but now you've got kind of this tail developing in the top. So it's going to change everything that's going on. So you've now reflected it across that axis. Go ahead and do these ones. Remember, the naked log, right, is base 10. All right, then these ones are going to be up. So 1, 2, 3, 4, 2. And remember to use your points. So that's our parent function here. And remember, you're going to go up 3. So all points will go up 3. I think that these ones are actually the easiest transformations, honestly. 1, 2, 3. All right. And then over here, we're going down. So again, this is a fairly repetitive process, but it's something that you guys need to make sure that you have down. You should be able to do this pretty much in your sleep. So if someone asks you to transform functions to save the country, you're ready to do it. Okay, and then now you go down 2 for each of them. And you see how this has affected your x-intercept here. So now that point will be your x-intercept instead. And the same thing will happen over here. You have a different x-intercept. All right, and finally, let's talk about these transformations. These are going to be our left and right shift, and these are the most interesting of the bunch, really. So you've got x minus 4, so you're going to shift to the right 4. So everything shifts to the right 4, 1, 2, 3, 4, and that'll actually put us off our page. So we'll just say this right here. The most interesting thing here is that my asymptote has moved. So normally with these functions, my asymptote is x equals 0, but now my new asymptote is x is equal to 4. All right, and then let's do this last one, and I'm just going to do the points this time. So shift them left 2, so 1, 2, 1, 2, and 1, 2. Ah, and cool. This also has given me now, not only do I have an x-intercept, but I have a y-intercept. So now I have a nice y-intercept here. I've got an x-intercept here, and I've got my asymptote, which is x equals -2. All right. So your reflection today is how are transformations of logarithmic functions related to the transformations of their inverse exponential functions? Think about that just for a little bit, write a sentence or two, and then go and get started on 7-52 logarithmic transformations. If you have any questions, let me know. Have a wonderful day. Goodbye.